Next up is Canadian UAV, Sean Greenwood. I actually know Sean. We met some time ago when he said there was some really important developments in the domain of aerial drones. So I'm confident I'm going to learn get an update this morning. So over to you, Sean.
Thank you. Yeah, a few years ago, before the pandemic,
True.
certainly a few updates. I'll just load the screen here. KUAVs, we're a Calgary-based a company founded here in Calgary, and this is where our head office is. We're roughly 7.5 years old now. Started in 2015 February, and since then we've been working on several different aspects. We basically have 3 different divisions: so commercial operations, military operations, as well as technology development. And we were recently approved by Lockheed Martin as a small unmanned systems distributor for Canada. So our big announcement is that this year we've been approved to fly Canada-wide BVLOS, which, for those of you who don't know, is basically the method of flying a UAV or a drone large distances, so beyond what the operator can see, or beyond the distance the operator can see the drone. This is regulated by Transport Canada. We've been working with them for roughly 6.5, 7 years to kind of phase build, rock or crawl, walk, run throughout the permitting process and the technology development. And what it really means is effectively the a pure economics of kind of the advertised hype of drones, drone menaces. By allowing beyond visual line of sight operations, we're able to capture very large area data with ultra high resolution imagery or whatever kind of sensor you're interested in using, or information you're interested in obtaining. Very significant amount of investment. We initially, had private funding. We got an NRC grant IRAP grant to initiate that, and then we were able to start a project with a defense company called Arcfield, which had offset obligations, which allowed them to invest in us for the next 5 years. So, just in terms of apples to apples, so ground-based observation versus visual line of sight, or kind of small scale drones versus manned aircraft and BVLOS. What we're seeing is basically the impact of certain MOB and DMOB costs. So visual line of sight is effective for smaller projects, roughly up to 5 square kilometers, for example. And then manned aircraft certainly is more competitive in large area mapping, so greater than 200 kilometers squared, for example. But for upstream pipeline inspection, which traditionally uses more helicopters, we're 30% or cheaper than that option. We also produce better data, so more repeatable, very, very tight tolerance flight planning, high accuracy information, so down to 1.5 centimeter per pixel, and then accuracy of in and around 5 centimeters X, Y, and Z. So this is pretty powerful, and again, what it allows is kind of 2 things: obviously immediate cost reduction, but also more frequent volume of inspection, and then higher fidelity of the information. So you're able to do the change detection analysis. You're able to understand, what's the current status of signage, third-party encroachment, all those kinds of things for pipeline inspection, but also for volumetrics in and around the oil sands region. So really understanding the mining operations and that impact on primary and secondary extraction for processing. So it's a pretty comprehensive capability, and it's really coming into the fold now because of these permits. So as I mentioned, we're going through a lot of basically research and development permitting from transport. Alberta's fantastically placed in the sense that we have one of 2 test ranges for unmanned systems in southern Alberta near Medicine Hat at the Foremost Test Range, and that's been enabling us to do a lot of pre-site assessment of the technology and the ConOps and training and maintenance of this capability prior to going into the oil and gas field. And as a result, we've been able to get the Canada-wide BVLOS permit. We also have a permit in the Wood Buffalo region for flying slightly higher, so 800 feet and below AGL. And we're also able to fly multiple UAVs or drones per radar deployment. So that really allows us to capture very, very large areas in a single day. Basically, as fast as you need it, we can capture that area. And to give you a bit of perspective, so the visual on a site radius is effectively 2 kilometers. This is as far as the eye can see a small drone legally. And then there's the only means of really getting a large area inspection is to use radar, or what's called a non-cooperative technology. So it's a bit of a rabbit hole, but in Canada, there's no mandatory transponder requirement for manned aircraft. And so therefore you have to have basically a radar to be able to see the airspace. We inspect and clear our own airspace or mitigate around that airspace traffic. And then deploy the UAVs. It's kind of like boat rules in the sense that power boats always have to give way to sailboats. So in our industry, unmanned systems always have to give way to manned systems. But as you can see, it's a pretty comprehensive capability, and this is just a single radar. We're able to network several radars together to give you more long linear corridors. But setting up this infrastructure at a site, you're putting it basically at your center of either your mine site or your conventional gas plant, and there's a spider network of upstream pipelines coming out of that, and we're effectively able to acquire all that data from a single location, and it's basically oil field data acquisition at scale. So ultra high resolution, lower. We don't have the same, we have ultra high resolution, ultra high accuracy, ground truthing, so ground control points involved in that, so survey grade data. The sensor profile we're able to do is basically anything we want, but we specialize in visual on a site, infrared inspection or heat detection, and multispectral analysis. And again, this is it's really the enabler to get to what we've been working towards for a number of years. And just quickly before I run out of time, but this is our current fleet. We're working with a number of very large manufacturers, really because of our setup in the sense that we're treating unmanned aircraft like manned aircraft in terms of maintenance and training and SOPs and operations manuals and that kind of thing. And we really need to have a lot of fidelity and trust with the OEMs to be able to do that because of how leading edge our technology is. We're the only ones to be approved to be able to do this in Canada. And we've been the first on a number of kind of record-setting permits and projects. We just finished doing a project in the fall with an oil and gas client, roughly 120 square kilometers, with again 1.6 centimeter per pixel resolution and 5.5 centimeter accuracy. So we have a fleet which goes from these small little buckyball drones, so they're able to go into internal processes and inspect, coking units or tanks. Really they're used quite a bit in secondary extraction. Rocks falling down through the kind of lube system and seeing what's going on before putting a person in there. We also do a lot of flare stack inspections, external plant operation inspections. So the dull, dirty, dangerous work. LiDAR with our LiDAR mapping in compressor stations, for example. And you can see on the far right, that's our beyond visualized site mapping rig. So really capable aircraft, and we have a number of additional aircraft coming in this year, which have greater endurance, more payload flexibility, longer ranges. So that's the 5-minute pitch. Yeah.
Great. Thank you, Sean. It's more the 9-minute 21-second pitch, but okay. There's a couple of questions on the Q&A for you to tackle, but in the interest of time, we're going to move on.
Sure.
But thanks for that.